Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ukobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 8, still on financial maths. It says Thabo bought a house for 980,000. He paid a deposit of 10% of the selling price of the house. He obtained a loan from the bank at an interest rate of 11% per annum, compounded monthly, to pay the balance of the selling price. He agreed to pay monthly installments of 10,000 on the loan. How much money did Thabo borrow from the bank? Okay, now let's understand this. Thabo was able to make a down payment or a deposit payment on the house of only 10%. When now he goes to the bank, he asks for the balance of the selling price, meaning that the balance of the selling price represents 90% of the selling price of the house. So in order to calculate that, we must understand that what he borrows from the bank is actually 90% of this amount, because he's able to make 10% of that amount as a deposit or down payment into purchasing the house, right? So to calculate that, a much more efficient way to calculate would be to say 980,000 multiplied by 90 over 100. Then simply we just punch that into our calculator. We end up with 882,000, right? Or if you prefer this way, you would first calculate the 10% of the amount, which would represent the deposit that Thabo makes. That's 90. So we have 980,000 multiplied by 10 over 100, which will give us 98,000. This represents the 10%, which is the one that was paid as a deposit. Now remember, we are looking for the balance, right? We are looking for what he actually borrows from the bank as a loan. So we will just say 980,000 minus 98,000, and then obviously when you subtract that one, you still get 882,000. So either way you could have calculated that, whether you just straightforwardly calculated using the 90%, or you first calculated the 10% for the deposit and then subtracted it from the selling price of the house. So either way it's correct. Okay, now let's proceed. We have 8.2. It says how many months will it take to repay the loan, right? So we are talking about the loan, so obviously the formula that has to apply is present value. Then we have x 1 minus 1 minus bracket 1 plus I to the exponent of negative n. So our present value formula, the present value, remember, we're gonna substitute the 882,000, because this is what he borrows from the bank. So this is the value of the loan. But then remember, they said he agrees to make a monthly installment of 10,000. So for x we must have 10,000 there. And then this is 1 minus 1 plus the interest 11%, so 0.11 over 12, and then to the exponent of negative n. So we are trying to calculate the number of months, so over 0.11 over 12. Now all we need to do here, the first thing that you do is divide both sides by this number here. So we will divide both sides by 10,000, right? So it's the same as multiplying by 1 over 10,000 both sides. So what I do on this side, I will also do on that side. Now if I say 882,000 divided by this 10,000 here, then I will get 88.2. Now immediately I cross multiply it with this denominator here, so it will be 0.11 over 12. So remember, I divided by 10,000, so this side here will only have 1 minus 1 plus 0.11 over 12 to the exponent of negative n. Now if I want to calculate, I can simply just take this over to this side, so it becomes a positive, and then over 12 to the exponent of negative n, and then now I will have 1. Take this one over to that side, that's 88.2, and then 0.11 over 12, right? Then at this point here, if we punch that into our calculator, that's 1 plus 0.11 over 12 to the exponent of negative n. Now what do we find from punching this? It's 0.1915. Then obviously to calculate your n, all you need to say is n is equal to negative log, and then here as your base you'll have the 1 plus 0.11 over 12, and then for this one here 0.1915. so we know the log function that we use is the one that goes log and then a block here and a block there, right? Then so for the block beneath here we substitute this one, and then for the upper block here we substitute that one. Then obviously because of this negative here we bring the negative before the log there. Now when you punch all that into your calculator you get 181.14 if we just round off to 2 decimal places, which we can say this is approximately 182 months, right? So remember the 0.14, it's telling you that there will be a final installment that is made, but then that final installment will not be an installment of 10,000. So the installment will probably be an amount that is way less than 10,000, but then it will be that final installment which will not be like the regular installments of the 10,000. So that's approximately 182 monthly installments that will be made, which will take obviously approximately 182 months. Okay, so with that we have concluded. Now let's go to 8.3. It says calculate the balance of his loan immediately after his 90th installment. So immediately after his 90th installment, note that in the previous question the number of months that we got was 181.14, right? Now to calculate the outstanding balance, we know that we'll use the present value formula. Just edit it, remove the PV, and then just write OB for outstanding balance. Then that's 1 plus I to the exponent of negative n over I. Now my monthly installment still the same, 10,000, and then I have 1 minus 1 plus interest still 11%. Now for the n here, remember I must if this person has made the 90th installment, what I need to substitute in here is the number of remaining payments that he needs to make after the 90th payment. So how do we find that? Simple, we just say 181.14 and then minus 90. Now we find that the number of remaining payments that he will need to make, it's 91.14. Then all we have to do is substitute that here, negative 91.14, and then just 0.11 over 12. Now you simply just punch all of this into your calculator, then you will find your value, that's 616,000.40, right? So that's your outstanding balance. This is the balance that will be left off to be paid after Thabo has already made 90 installments into paying off the loan. So the remaining balance or the outstanding balance will be this amount here, right? Okay, so 8.4 says Thabo experienced financial difficulties after the 90th installment and did not pay the 91st to the 95th installment. At the end of the 96th month, he increased his monthly installment so as to pay off the loan in the same time interval as planned initially. Calculate the value of his new monthly installment. So now Thabo realized that he missed 5 payments. So this is what we refer to as a deferred payments. So we refer to that as deferred payments. So he realized that he missed 5 monthly installments. So now he still wants to repay the loan within the stipulated time here, which was 181.14 months. But then in order to do that, he realizes that he no longer has to make monthly installments of the 10,000, but would need to increase the value of his monthly installments, right? So let's understand this. This relates very much to 8.3 here, because in 8.3, remember, we just calculated the outstanding balance of the loan after the 90th payment, which was 616,000.40. Now remember, immediately after that 90th installment has been made, he is no longer able to make 5 consecutive monthly installments. Now the bank, what will it do? It will say, okay, we are a business, and then we can't just pause on the loan. For the 5 months in which you were unable to pay, we will take the present value amount here, the value of the loan, and compound it over those 5 months in which you were unable to pay. So that when you now resume your payments on the 96th payment, you are no longer owing this amount, but now you are owing that amount along with the interest for the 5 months that you were unable to pay. Right. So now the first thing that will happen is that the value of the loan will be compounded over the 5 months whereby payments were missed. Then that's 1 plus 0.11 over 12 and then 5, right? So now over the 5 months, the value of the loan will compound to 644,755.711. So this is now the value of the loan at T96, right? But then remember, as soon as it starts making payment there, T96, he still wants to complete the loan at T181.14. Now, what are the remaining number of installments that they need to make? Now, to calculate that, note here, we don't just say 181.14 minus 96. We need to say upper value minus lower value plus 1, which means we'll say 181.14 minus 96 plus 1. Why are we saying plus 1? It's because we understand that in counting here, we'll be starting exactly from 96. So we counted the 96, then 97, and then if you count all that, obviously you need to include the plus 1. To make a practical example, let's say we have T5 and then we want to get to T10. Now, a lot of you can argue that there will be 5 month installments that will be made here. But if we are saying we are starting exactly at T5, then it's actually 6 month installments that will be made, because we'll be counting T5 and then T6, T7, T8, T9, and also T10. Now, if you count here, how many? It's 1, 2, 3, 4, 5, 6. So yes, 6. So it's T5, T6, T7, T8, T9, and then T10. Pardon me for that. So that's exactly 6 monthly installments, right? So 6 monthly installments. So you can see that, right? So that's the whole idea I was trying to make it there. Now, if you just punch this into your calculator, you will get 85.14. So I hope you understand that. Now, to calculate my present value, that's PV is equals to X, and then 1 minus 1 plus I to the exponent of negative N, and then over I, right? Now, remember, I'm trying to calculate X, but then my present value, I will now have to use this amount here that is accumulated. 644,755.711 is equals to X. And then here I have 1 minus 1 plus the interest is 0.11 over 12. But then the N here will have to be the 85.14. These are the remaining number of installments that needs to be made. Then 0.11 over 12. Now, to calculate X, we already know the trick. Take this cross multiply with that, and then take all of this over to the denominator. So that's 644,755.711, and then times 0.11 over 12, and then all over 1 minus bracket 1 plus 0.11 over 12 to the exponent of negative 85.14. Then simply punch all of that into your calculator. Then you will find that your new monthly installments now will have to be 11,280.92. So if you can just compare here, you can see that is added about 1,280.92 extra from the initial monthly installment that he was making. So from that you can see that the 5 months that he has missed has actually cost him a lot, right? But then he was able to recover from that just by increasing his monthly installment, and was still able to finish off the loan within the same time interval as planned initially. So that's how you were supposed to go about tackling that question, all for a total of 16 marks as a whole. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.